Welcome to part 11 of the Java Learning Series by TECHMargadarshi. In this part, we will explore the map interface in Java, which is used to store data in key value pairs. Map is a part of the Java collection framework that stores data in the form of key value pairs. Each element consists of a unique key and a corresponding value. In a map, duplicate keys are not allowed, but duplicate values are permitted. Unlike list and set, map does not guarantee any order. This depends on the specific implementation used. Map belongs to the java.util package, but it is important to note that it does not extend the collection interface, making it different from other collection types. We mainly use map when we need fast data retrieval based on keys, such as storing student records, employee details, or configuration data. Common implementations of map include HashMap, LinkedHashMap, TreeMap, and Hashtable, which we will explore in detail in the upcoming slides. Now let's understand the map hierarchy in Java. At the top, we have the map interface, which stores data in key value pairs. HashMap is the most commonly used implementation and does not maintain any order. LinkedHashMap maintains insertion order, while TreeMap stores keys in sorted order. We also have Hashtable, a legacy class that is thread safe but does not allow null values. Understanding these implementations helps us choose the right map based on our requirements. Now let's understand HashMap in Java. HashMap is a class that implements the map interface and stores data in key value pairs. It does not maintain any insertion order, and the output may appear random. HashMap does not allow duplicate keys, but it allows duplicate values. If a duplicate key is added, the old value is replaced. It allows one null key and multiple null values. Internally, HashMap uses a hash table, which makes operations like put, get, and remove very fast, usually in constant time. However, HashMap is not thread safe, so synchronization is required in multi-threaded environments. We use HashMap when we need fast data retrieval using keys, such as storing user data, configurations, or caching. Let's look at a simple HashMap example in Java. First, we import the HashMap class and create a map with integer keys and string values. We add elements using the put method. When we insert a duplicate key, like key 2 again, the old value is replaced with the new value. When we print the map, the output may not follow insertion order. Using the get method, we retrieve the value associated with a specific key. The contents key method checks whether a key exists in the map. We then remove an element using the remove method. Finally, the size method returns the number of key value pairs present in the map. This example clearly shows how HashMap works with key value data and provides fast access using keys. Now let's understand linked HashMap in Java. Linked HashMap is a class that implements the map interface and maintains the insertion order of keys. This means elements are stored and retrieved in the same order in which they are added. Like HashMap, it does not allow duplicate keys but allows duplicate values. If a duplicate key is inserted, the old value is replaced. It also allows one nil key and multiple null values. Internally, linked HashMap uses a combination of a hash table and a doubly linked list to maintain order. Because of this, it is slightly slower than HashMap, but provides predictable iteration order. We use linked HashMap when both key value mapping and insertion order are important, such as in caching, logs, or maintaining history. Let's look at a linked HashMap example in Java. First, we import the linked HashMap class and create a map with integer keys and string values. We add elements using the put method. When we insert a duplicate key, like key 2 again, the value gets replaced with the new one. When we print the map, notice that the elements are displayed in the same order they were inserted. Using the get method, we retrieve the value for a specific key. We remove an element using the remove method and print the updated map. The containers key method helps us check if a key exists, and the size method returns the number of key value pairs. This example clearly shows how LinkedHashMap maintains insertion order while storing key value data. Now, let's understand TreeMap in Java. TreeMap is a class that implements the sorted map and navigable map interfaces and stores data in key value pairs. The key feature of TreeMap is that it maintains keys in sorted order, by default in ascending order. TreeMap does not allow duplicate keys but allows duplicate values. If a duplicate key is added, the old value is replaced. It does not allow null keys because sorting requires comparison, but it allows null values. Internally, TreeMap uses a red black tree, which is a self balancing binary search tree. Because of this, operations like add, remove, and search take logarithmic time. TreeMap also provides navigation methods like first key, last key, higher key, and lower key for working with sorted data. We use TreeMap when we need data to be stored and processed in a sorted manner, such as in rankings, reports, or ordered data. Let's look at a TreeMap example in Java. First, we import the TreeMap class and create a map with integer keys and string values. When we add elements, the keys are automatically stored in sorted order. Even though we insert keys in a different order, the output is arranged in ascending order. If we insert a duplicate key, like key 2 again, the value is replaced with the new one. Using the get method, we retrieve the value associated with the key. TreeMap also provides useful navigation methods. The first key method returns the smallest key, last key returns the largest key, higher key gives the next higher key, and lower key gives the next lower key. We then remove an element using the remove method, and the size method returns the total number of entries. This example clearly shows how TreeMap maintains sorted key value pairs and supports efficient navigation operations. Now let's understand Hashtable in Java. Hashtable is a legacy class that implements the map interface and stores data in key value pairs. It does not maintain insertion order, similar to HashMap. Hashtable does not allow duplicate keys, but allows duplicate values. However, unlike HashMap, it does not allow null keys or null values. One important feature of Hashtable is that it is thread safe, as all its methods are synchronized. This makes it suitable for multi-threaded environments. However, due to this synchronization, Hashtable is slower compared to HashMap. Since it is a legacy class, it is rarely used in modern applications, and HashMap or concurrent HashMap is generally preferred. Hashtable is mainly used when thread safety is required in older systems. Let's look at a hashtable example in Java. First, we import the hashtable class and create a hashtable with integer keys and string values. We add elements using the put method. Hashtable stores data in key value pairs, similar to HashMap. When we print the hashtable, the output may not follow insertion order. Using the get method, we retrieve the value for a specific key. The contains key method checks whether a key exists. We then remove an element using the remove method. Finally, the size method returns the total number of key value pairs. This example shows how hashtable works with synchronized methods, making it thread safe but slightly slower compared to HashMap. That brings us to the end of part 11 on the map interface in Java. We explored HashMap, LinkedHashMap, TreeMap, and Hashtable, along with their differences and use cases. Practice these examples to clearly understand how key value mapping works in real world applications. Stay connected with Tech Margadarshi for the next part of our Java learning series.